I want to start off with saying that I'm really glad to be here, and the conference has been great. Lots of interesting talks, wide diversity, and it's been very interesting. And now on to the least interesting topic of this conference. It's internationalization. And what does that mean? It means to prepare your product for an international audience, an international customer base. And for software, that means supporting your user interface in multiple natural languages. And if you've been exposed to internationalization as a programmer, I bet you weren't very enthusiastic about it. Why not? Personally, I'm a naval architect. I like solving problems for that regard shipbuilding, and that's what motivates me. And internationalization is just not in that set. It's just an annoying user specification that needs to be met somehow. So I'm going to present a project, a dub package that I wrote, that aims to make internationalization as much of a breeze as possible. And I think that might be interesting. The package, of which you see the logo in the top right, is called gettext, after the well-established gettext system, which is more of an ecosystem, and this package lets you tap into that. And I should mention that I didn't invent the ideas that you'll see presented here. I just did the work, and others deserve a lot of credit, but more on that later. Let's start with a poll. I've seen people doing that. It's always great for engagement. This being an international conference, raise your hand if your native language is not English, or if you live in a country where English is not the native language. Oh, wow, that's maybe 80% here. Great. So, all of you know that, maybe not yourself, but at least you know people that prefer to interact with their devices and systems in their native language. And even though English is the lingua franca of computer programming, the annoying fact is that if you want to increase your customer base, you'll have to deal with internationalization at some point. In this talk, I'll be giving an example of how you internationalize your code using this package. And in the end, I'll highlight some of its implementation and how it uses D features to achieve its magic. Before that, let's quickly review the ways in which internationalization is tackled in the industry to get an idea of the state of the art. I'll start with what we have been doing thus far, and I'm not ashamed to share this because we could have been in a worse place, as we'll maybe see later. As I've presented in previous tasks, most of our decode is machine translated from Pascal. In Pascal, we were used to do everything ourselves, and so we have been using a homegrown system for internationalization. And that system translated the complete source code. So we were building a different version of every program for all languages that we support. This comes with a myriad of disadvantages. But the fortunate case of our situation is that since we're transcompiling anyway, we might as well transcompile to a different string syntax that allows us to use a different system for internationalization. So we can just pick and choose the best one. As it turns out, there are solutions that are platform-specific, language-specific, and framework-specific. And I'll show one of each category. Although we prefer to be platform independent, Microsoft Windows has been strong in internationalizing its products for a long time. So let's look at their Hello World multilingual user interface example on Learn Microsoft. Yeah, apparently internationalization is not trivial. And you can scan the QR code on the top right if you want to have a closer look. And that code will change on the further slides to get you to the link that is relevant for that slide. So let's zoom in to the top and see what it starts with. Hash defined sufficiently large string buffer. Max path times 2. Okay, let's scroll down. Luckily, there are a lot of comments, because otherwise you wouldn't be able to make sense of it at all. And I'll treat a beer to anyone that spots the string that is actually being translated. I have no problems making such promises because it's not here. There we are. So this is where the meat is. There, you use load library to dynamically load the resource of the specific language. And here you have a buffer of white char that is of sufficient size. And then we use load string to fill that buffer. And there. And how do we know what to fill it with? We fill it, you know it by an idea. There, hello, mu string 0. All strings that you see in this code are untranslatable, and the only translatable string is hidden behind an identifier. Then the example shows how to format the buffer with a translated string into there another buffer. And that buffer is displayed in a message box. All right. Hope you've been following along. This is a very good example of what not to do. That's what I meant. This, from a programmer's perspective, this is way worse than what we have been doing. And the biggest problem is that you don't see the contents of the translatable string. It's just an ID. You have no idea what it represents. I'm guessing it means hello. And another interesting thing, what do you do if you can't find the translation of that string? You tell your user, sorry, can't go on. We just terminate the program. And there are no plural forms, and plural forms are an interesting aspect of internationalization. So moving on to a language. First I looked at C#, but it's the same mess. This is Java, and it's very refreshing to see an example that fits on one slide. And the important thing is just these last 4 lines. You load a resource, you look up the strings, and you print them. It's a bit verbose, but maybe Java people are used to that. And very nice is that the key is actually a string. So it's all good then? Sadly, no. The tutorial stresses that the strings in the code, here greetings, inquiry, and farewell, they're definitely not the strings that are displayed in the user interface. So they're just keys, only in the form of a string somehow, for some reason. And that comes clear if you see actually the translation table. That's the translation table used in the example. And I don't think you can use white space in the key or equal signs. So that's limiting. And the tutorial is not clear what happens if you can't find the string. I think an exception or something. The last reference that I want to review is the highly popular Qt framework, or Qt. And it goes like this from the Qt documentation on internationalization. First example is if you have a string literal that needs to be translated, you just prepend it or embed it in that tr function. And compared to what we have seen so far, this is very elegant. The default translation is in fact the key for the lookup. And if a translation is incomplete or even non-existent, then the string literal that is in the code is the string that is presented to the user. It is very concise and expressive at the same time, and very programmer-friendly. Format strings follow naturally from the functionality of the Qt string class. Strings with different meanings, but the same key or contents, they might need to be translated differently in other languages, and so you can differentiate them with a context. So the thing to remember is which parameter is actually the string and what is the context. But okay. Then plural forms are supported by supplying a counter as a second optional parameter. And in this case, we didn't need a context, so you had to supply an empty string, which is a bit meh. Because actually, it's more often that you need a plural string without context than one with. So this is a common side. But nevertheless, all in all, the Qt offering does tick all the boxes in my eyes in terms of capabilities, legibility, and maintainability. As we'll discover, the Qt developers have read a few pages of the gettext book. And the only thing is, you need Qt, which is not easily paired with D, sadly, not the least because they use an additional preprocessor of their own. In any case, you wouldn't want to need to pull in all of Qt if you just need internationalization. A solution that is framework agnostic and platform agnostic is preferable. So enter gettext. Oh yeah, one last thing. You can pass comments to the translator, which is very nice. And the syntax is that you use an ordinary C++ comment with a special tag in it. There, gettext then. This is the Wikipedia page. Its initial release was in 1990, 33 years ago. Initially, it was targeted at Unix-like platforms and the C language. After GNU came up with its implementation in 1995, it was eventually made multi-platform and also supporting many languages. So clearly, gettext has had a long time to grow and become widely used, which has led to the emergence of some kind of an ecosystem. What do I mean by that? The ecosystem consists of the GNU gettext system on the one side and third parties on the other side. Among the GNU gettext command utilities, you have a scanner for string extraction, a tool for initialization of a table for a new language, which sets some default settings, typically for that language. And you have tools for merging of existing tables, updating tables with changes that happened in the code. And you have a utility for converting a text form of the table into a binary form that's used for distribution. And there's several other utilities. Then you have the runtime part of the system. It takes care of string lookups in those tables. and also for a selection of the right language. And then you have third-party tools. You have your editors with their modes and plugins and extensions that do syntax highlighting for your text-based translation tables, if you want to use that. There are even dedicated editors that are very user-friendly. One example of which we'll see a screenshot later. You can just fire it up, load a translation template, select the language that you're going to translate to, and then you just see the source strings and what should be the target strings. And if you pay for a subscription, you can even use AI translation services that do most of the work, and you just have to review it. And it also sets the correct plural forms for different languages, because many languages don't have just two plural forms, singular and plural. Yeah, those are the translation APIs, and then we have partners. There are professional translation services that just know how to deal with the gettext format, and so that can be very helpful. And a very important principle of gettext is that software development is decoupled from translation efforts. And with the third-party editors, the translator experience is good enough that even an enthusiastic customer can contribute to the translation. As we'll see shortly, my gettext package takes care of string extraction and the runtime. And for the rest, it ties into this existing ecosystem. But before looking at this situation, let's briefly look at how GNU gettext is used in C, the way it was designed to be used. Because maybe we can give D programmers a better experience than C programmers. So here we have C. I'm using bold for the bits that regard internationalization to highlight the signal-to-noise ratio. And the features of gettext are that, as with Qt, the original English text is the key for the lookup in the translation table. So the programmer intent is clear. And if the lookup fails or no table has been loaded, the original English text is used, and multiple identical strings are translated only once. Comments can be used to translators, passed to translators by special syntax, like with Qt, and these apply to the marked string that immediately follows the comment. If you use identical strings with different meanings, again, you can define the context, but you have to use a different function, pgettext. I don't know what the P stands for, but this is how it is. And plural forms are handled by yet another function, gettext. And sadly, you have to repeat the number that defines the plurality, here n, once for the gettext function and once for printf. And since translation is a runtime event, when you have constants involved, there are some hoops to jump through. These are actually the strings that you want translated, so the scanner needs to somehow discover them. So you have to define a macro that does nothing but helps the scanner, because you can't translate it at compile time, so you can't use it for initialization of constants. And then, I don't know if you can see this, but then you have to call gettext functions on something that is not a string literal. So it's a bit confusing and cumbersome. Both gettext and Qt take the right approach with the translatable strings being keys for the lookup. And Qt has been able to improve a little on the syntax compared to gettext. But GNU gettext has the advantage that it is self-contained and independent, which makes it excellent as a choice for the foundation of a D implementation, in my opinion. So, on to the D experience. You get the package from the DUB registry at this URL. And as you see here, it features concise translation markers. You just prepend tr-bang to the string literal. And I chose tr-bang because, or tr, because I think the original gettext keyword is too long. Even the GNU manual acknowledges this, and what they suggest is that you define a macro underscore to mean gettext. But I don't want to lay claim on underscore in the global namespace, and besides, there's no hint that it regards to internationalization. So tr is the better choice, I think, because it hints at translate. And I like that there are no additional braces, parentheses. It's one character less than the C option. But if you want the GNU style, you can do this. And there's no other changes, configurations that need to be made to the scanner or something to make this work. I have a question. How many ways are there in D-Lang to write down a string literal? There are 9. Yeah, 9. There are 9 different ways, and all of them are supported. Here are some of them. This is an ordinary double-quoted string, which may have escape codes. We have WYSIWYG strings that don't need escaping of special characters. This is another WYSIWYG string, less popular, but nevertheless, it's there. This is one of 5 forms of delimited strings, and you can choose your own delimiters even. And I can't imagine why anyone would want to translate source code into another natural language, but it comes at no additional cost. So here it is as an example. If at any point D should introduce yet another string syntax, I wouldn't be surprised if this package just would support it without an additional change. The reason of which I'll come back to later. So, plural forms. Support for correct plural forms is a central feature of gettext. And without support for plural forms, one would possibly use a formatted write line with an ambiguous form and let the user autocorrect while reading. Here, %d is a placeholder in which the value of n is substituted per write line. Or if you want it to be grammatically correct in English, you could do something like this. The difficulty with plurality is that many languages have more than 2 plural forms, and that each language has its own rules for what is the correct way. And gettext solves this. Using this package, what you do is that you supply the English singular and plural forms as the first and second compile time argument to tr, and the number as a runtime argument. Here gettext will substitute %d with n, so the translated string has no placeholders. Hence the write f line can be changed into a write line. And note that the variable n is only supplied once in contrast to the GNU gettext implementation. Gettext will select the correct plural form depending on n for the currently selected language. Supplying these individual forms is the task of the translator, and it's completely separate from development. So this is taken care of by the ecosystem, and the programmer doesn't need to worry about it. So we are coming from Pascal, and Pascal does not support format strings, at least not the version that we were using. So many of our strings are compound strings that consist of a concatenation of string literals and string variables like this. I took extra care to support this, and this works. But it is bad practice because translators will only see fragments of sentences, and they don't know in which order they are used in the user interface. So in order to enable translators to provide correct translations, programmers should strive to present them with complete sentences as much as possible using format strings. Here the %s is a placeholder for the value of player. The nice thing is that you can use plural forms in format strings or vice versa. Here n is an argument to tr and player is an argument to right of line. TR will substitute %d with the value of n, so right of line will never see the %d placeholder. And you may ask at this point, how does TR know which of these two placeholders to replace? Well, it always picks the one with the highest order, so %d in this case. And what if we want to pick a different one? Well, luckily, format strings allow you to define an explicit order. Consider this somewhat contrived example. In this non-internationalized code, we iterate over hand and bush. So I is first 0 and then 1, and where is first hand and bush, then bush. Each iteration does a formatted right line, differentiated for plurality, where I+1 replaces %d and where replaces %s. So if you execute this, you get 1 bird in the hand and then 2 birds in the bush. So here the first placeholder, %d, is what corresponds with the plurality. And we can internationalize this like so. Each iteration, we have the 2 compile time arguments to tr and its runtime argument, and where is the second argument to right of line. The $1 and $2 that are inserted into the placeholders specify an explicit order. %2d is the placeholder of the highest order, so that is the one that TR will replace. Again, right of line will never see the $2d placeholder, as TR will have filtered out the highest order of placeholder in the translation. And the fact that format strings support explicit ordering of placeholders is actually very important regarding internationalization, because sentences with multiple placeholders and arguments may require a different order in some languages. By using explicit orders in format specifiers, translators can reorder the arguments as required in their language. It's kind of the same as this room contains 75 attendants versus 75 attendants are in this room. Depending on the language, one version may be more natural than the other. And it doesn't matter if you as a programmer haven't ordered the arguments. The arguments only matter in the runtime execution of the format, so that the translator can introduce order if needed. There are a lot of things you can do with format strings. It is a mini language with its own grammar, inherited from C. It is not the most accessible language I know, but it is fairly well documented on the format page of the dstandard library. Next up are comments to translators. Comments to translators can be passed as an optional parameter by wrapping them in the comment struct. I think this is nicer than the approach taken by GNU gettext and Qt that use specially formatted code comments, because in this case, you don't risk accidentally detaching the comment from the string that it applies to. And by the way, translating proper names is not a bad idea. When translated to Japanese, for example, the translator will want to approximate the pronunciation of the name in a katakana script. And by using the International Phonetic Alphabet, in the comment, the correct pronunciation can be communicated to the translator. Differentiating by context follows the same principle. Here we have 2 identical source strings that may need individual translation. And in the second case, we pass more information to the translator to make sure we get correct translations, so they can be combined. Actually, in this example, I could have omitted the context document in the first one, because if one string has a context and the other one doesn't, it is enough to differentiate the translations. And of course, plural forms also support comments and context. I think the approach with wrapping structs is very neat. It sets those arguments apart from the context strings. Otherwise, they all would be strings. You wouldn't know what they mean. So we can also avoid awkward null arguments like the Qt approach. So translation is a runtime thing, or at least we have chosen it to be. So it's not surprising that runtime variables can take the value of translated strings. Here are some examples that may surprise you. We have compile time constants. We have enum members. And enums only exist during compilation, right? And static initializers. I'm not saying that this is good form. My point is that this is working code. And it works because we let the type be inferred. If you require the type to be string, you get a compile time error. But if you leave that out, it just works. I don't think there is any other programming language where you get this. And the nice thing about this just working is that this requires very little cognitive overhead of the programmer. The internationalized code looks almost identical to non-internationalized code. But it's not just nice. In my job as a transpiler operator, it is very important. Since we previously came from translating source code before compilation, translatable constants are not at all uncommon. So we don't need many manual rewrites, it just works. At this time, it's probably nice to review an example that we've seen before. This is the hoops that C folks have to jump through. You have to define markers that seemingly do nothing, mark different string literals in different ways, and marks things that aren't string literals. It is very convoluted, laborious, and confusing. In D, you just mark your string literals, and you're done. The rest is pure programming logic. The signal-to-noise ratio is very high. And that's all, API-wise. I think the level of comfort of this API is in line with what we are used to in D, and I like it. One more thing. Here's a string mixin. The tr-bang marker is embedded into another string, which could even be the result of compile time function evaluation. This is not a problem for this package. Now that we've seen the intricacies of the API, or rather the lack of intricacies, I'll walk you through the process of internationalizing a dub project. So I'm going to start with a project that you get after invocation of dub init. You have your D code at the file, source file at the top, and your dub.json underneath. And if you issue dub run, you get this, which prints edit source app D to start your project. So first step is to mark the strings that you want translated. Here in bold, tr-bang. And you add a dependency in dub.json to the gettext package that you import in the source file, of course. If you run it, the program works just as before. It displays the string literal, even though no translations exist yet. And as long as you just want to be ready for internationalization, this is all you need to do. Or if you work in a team and dealing with actual translations is not your responsibility, there's nothing else to do either. But when the time comes to actually generate translation tables, this is what comes next. First step is to install the GNU gettext utilities. And by the way, the only downloads that you need on your dev machine only. None of this needs to be deployed. For Windows, there are precompiled binaries. For Mac, you have Mac ports and the like. For Linux, you obviously use your package manager. Second step is to paste this blob of text in dub.json. You most probably can leave this unchanged, but we'll briefly explain what it does. It inserts a bunch of configurations. The first one is just empty. which means that if you don't specify configuration, it does nothing special. Then we have a configuration abbreviated internationalization. The 18 there replaces the 18 characters in the word internationalization. The thing is that it adds a few pre-generate commands. So these are commands that are always executed. It runs another configuration. It actually executes that compile also. And the config is named gettext after the utility that it replaces. And it's going to extract the strings from your sources. After that's done, you get merge. That's a sub-package of the gettext package, which calls the GNU gettext utilities for updating your translations with changes in the code. And then po2mo converts the text file tables to binary files, which are then copied into your target directory. And on the bottom, this is the gettext configuration. It hides the result of that compilation in a different target path. It switches on a specialized version, and it also switches on a specialized version in the gettext package. The third step is to invoke .build --config equals internationalization, and this generates the pod file, and it's a template file. And since there are no translation tables yet, there are some warnings. I'll speed up a little bit. Maybe we can skip a few bits of this. What happens here? The invocation of message init, which is a tool. You initialize a table for a new language, Dutch in this case. It looks almost the same as the language field has been filled in, as well as the rule for plural forms has been added. So, and here you fill in your actual translation, and by invoking the same run with the internationalization configuration, it now generates the translation tables. So now we have both a PO and a MO file in the products for each translation. The only thing left to do is add some logic to our program to select a language, and now an ordinary dub run lets me enjoy my program in my native language. So this is a quick screenshot of the PO-edit editor that I was referencing, and this is an example of a language that has 3 plural forms. To conclude a little bit about the ideas on which the implementation of this package is founded. And this is primarily a testament to our forums and the community that we have. This is a post by HSTL from about 3.5 years ago. And I was actually going to read this out, but maybe you just scan the QR code. But it's a very nice idea that he had. And it works like this. His proof of concept stretches over several short files. The most important one is looking like this. And this covers the string extraction. String lookup is ignored. So when version extract string is on, we see that there is a global dictionary defined, and the main function that writes out the contents of that library, of that dictionary. Secondly, there's a template taking a string argument, and which version, when version extract string is on, a module constructor is injected that inserts the string into the dictionary. For the rest, there is a function with the same name, making this an eponymous template, which returns the same string or its translation. The other files are just examples of calls to the template function to demonstrate how all marked strings in all the sources are discovered. And you can see that the ordinary main function is ignored in the extract string version. And executing this in the string version prints out the stub for another dictionary. Here it is. That can be filled out to form a translation table. I had bookmarked this as a wonderful idea, and in the replies to this post, you'll see that he wasn't the first one either to have it. But since then, I had not yet seen this built out to cover the full feature set of GNU gettext. When I decided that it would be me to try and do this, I found a dub package, mofile, that reads the binary gettext format. So that came in very handy, and all was merry. Until I realized that for every translatable string, this instantiates a template function, string gettext. When we have a ton of these strings and bloating our executables just to get internationalization working, and only because we have a cool way to scan for strings, that didn't sit well with me. And so I returned back to the forums with a cry for help. This time, Steven Zwijghover was quick to reply, saying, "Let me dust off my wand." And the nice thing of this is that the internationalized string does not have a bigger footprint than an ordinary string. What happens is that the template, when you run without extra versions, it just reduces to an idiom that instantiates a struct that wraps a string. So nothing more than a string remains after instantiation, which is the same footprint as that you had before. So this got me excited again, and this discussion went on with a few more equally valuable iterations, which you can see under the QR code. And the end result that I demonstrated earlier is a little bit more involved than these short snippets. Totally, maybe 800 lines of code. But those are the core nuggets that made this little project a success, which I think it is. So, quick conclusions. D now has an internationalization solution that is best in class, to the best of my knowledge. It is minimally invasive. The internationalization details do not obfuscate the code that really matters. Functionality is practically on par with GNU gettext. It is easily integrated in dub configuration, and translation efforts are supported by the GNU ecosystem. So it's just to use the package and report any issues. Thank you.
Firstly, I want to say this is fantastic work. Translation is like a serious problem in a lot of different languages, and it's especially tricky because everyone thinks they know how to solve it, and so developers often immediately go and run off implementing their own solutions, and they don't know that there's languages that it's based on sound, not numbers. So 21, 31, and 41 all have the same ending, for example. So that's it's a classic one. So my question is, I've noticed everything was based on compile time strings, but like in a web server, for example, the locale arrives via a header. So what options exist for a runtime configuration and look up the language? And also for the compile time, I didn't see in the examples, how do you actually select the locale?
Oh, yeah. I think I jumped over that. I have a few functions that just inspect your installation and discover mo files and returns that in a slice. Then you select one of those. And runtime, the header, you don't know the header's existence before compilation? I know 5D uses a similar approach, and I'm not sure if, but 5D generates mostly static, the templates are mostly static, right?
So often the same service will have users from all across the world.
Yeah.
And each one at runtime can configure the locale, or even change, the same user can change their locale.
Yeah, so that's what you mean with the header. Yeah, it's session dependent.
Yeah, it's session dependent.
No, I think that will work. You just have to switch languages more often. So you have to look up the string. You shouldn't cache it between sessions. Should work, I think. Because the only thing that is compile time is the original string, the English string, which is used for a key. And the key doesn't change in between languages.
I wonder, there are many languages. You show the example of having a flexible way for plurals, but like was already mentioned, there are many language features, like the English just has one article, the other languages have like the, does, they, and there. So does gettext provide more like complex things that you didn't show, or are translators on their own to creatively solve language problems?
Yeah, I don't believe it offers much more features that support that. But the most important thing is to pass as complete sentences as possible to the translator. And then it's the translator's job to use the correct grammar. Do you think that will work?
Yes.
Luckily, I don't need internationalization in my tools. It's all English, but pluralization is always an issue.
What is an issue?
Pluralization, like
plural. Okay.
Yeah. So I started a solution by myself. I like the idea that the single form and the multiple form are provided twice, but it also feels a little dirty because they are mostly the same string. I was wondering whether getting a little too complicated, describing, with a domain-specific language, basically, they're describing this noun depends on that parameter argument, plural form, and put this way plural or not. So I was experimenting with it, but it got also complicated on its own. Just wanted to comment.
Yeah, on the messy aspect, you could, for example, decide to just, in one example, I used singular parentheses as parentheses. But that means that you always have to use a translation table also if you just want English to be displayed plurally correct. So you don't have a runtime fallback that is as feature correct as.
So I think a different solution, maybe a simpler solution only for pluralization, is still needed for English, at least, because of the lingua franca.
Yeah.
Yeah, I actually have a comment to add to that, because we use translation services all the time in the video games industry, and they just want simple strings to translate. So there's economies of scale that you need to take into account there instead of trying to be clever about it. So
one thing people may not realize is that by following a standard format, these PO files, there's online tools for people to use, like PO Editor. And that means you can hire external companies. They'll do all the work. They know all the tools. They can give you the data. Everything becomes much simpler when you have a standard format like this. So this is a massive addition to the D language.
Before you wrap up, I have one additional comment. Yeah, so just in case anyone was going to ask this, I'll ask it myself. So the question is, why not just use libdparse? And I know the answer to this because I wrote there's another subpackage which uses libdparse to discover untranslated strings, because you might want to look, am I complete? Where are the strings that I have overlooked? And it uses libdparse. But the nice thing of this approach is, the problem with the libdparse approach is that when the D grammar is going to change, libdparse needs to be updated, even if it's not string related. And then you have to recompile this package. And now this is just maintenance-free software.
Would you consider using dmd-as-a-library?
Yeah, well, that's nice, but still you have to recompile because you have to use the new DMD library, which has the new grammar. This is just built in. There's nothing It adapts. Even if you go compile with a DMD version that's 10 years old, or then 10 years in the future, it'll just work.
All right, let's wrap it up there. Thank you.
Thank you.